In this video, I'm going to show how you can write a reciprocal function when you're given a graph and a point, and also how to graph and find the point of discontinuity. So in this first one, let's write a reciprocal function when given a graph and a point. Now for this one, the format is going to be y equals a over, this will be our x minus h, and then I have a plus k. Now for this one, we need to identify our asymptote lines. Our vertical asymptote is whatever h is going to be. So if I look at my graph, I want to focus in on the red lines, or like you think of the purple lines. And I got to think, where is the vertical asymptote? And so I'm going to trace where the vertical asymptote line is, and that is right here. It's at -4. So if the vertical asymptote is at -4, my h right here is actually going to be x minus a -4, which really means I'm +4. My k is going to be my horizontal asymptote. And if I look here, the horizontal asymptote line would be right here. And I can identify the asymptotes from this line, from this graph, because the graphs always approach the vertical and the horizontal asymptotes. So they're approaching the horizontal asymptote line at -2. That means my k is going to be -2. So on the side here, I'm going to say h, the vertical asymptote was at -4. My constant, or not my constant, my k, which is my horizontal asymptote, this is at -2. Now I have to choose a point, but they give us a point, and we're going to use that point. That point is right here, -3, 3. So my x is going to be -3, and my y is going to be a +3. And I'm going to plug all those numbers into my equation above here so I can find a. So my y is 3, equaling, I don't know my a, so I'm going to put an a there. On the bottom, my x is -3 minus my h is a -4, and then my k is a -2. So now from this point, I'm going to add 2 to both sides. And now I have 5 equaling a all over -3 minus a -4 really means 1. If I multiply by 1 on both sides, I now have 5 equaling a. So my equation would now be y equals 5 all over x. Instead of putting a minus sign, it's now +4. And then my horizontal asymptote line would be a -2. And this would be my reciprocal function when given a graph, this particular graph, and the point 3. Moving on to our next example. Our next example is referring to graphing the following function, f of x equaling x plus 3 squared divided by x plus 3, and then we're going to find the point of discontinuity. So in order to do this, we still need to find we will still find our asymptote, but the first thing I'm going to do here is I'm going to factor my numerator. So if I factor the numerator, this is going to be, actually not factor, but break it apart. So this is really x plus 3 times x plus 3. And then in the denominator, I have an x plus 3. And I want to simplify this. There's an x plus 3 in the numerator and an x plus 3 in the denominator that divide out. Because they divide out, that means I'm going to have a hole for that area where x can't equal 0. So if I have x plus 3, it can't equal 0. Because remember, if I have that in the denominator, whatever that is, whatever x would be, it just can't make sure it equals 0. So I would subtract 3 here, and I would have x equaling a negative 3. That means if x is negative 3, I cannot solve it. So right now, I'm going to come to my graph. My coordinate plane is going to be counted by 1s, by the way. And I'm going to put a vertical asymptote at x equaling negative 3. That means any point that lands on that line, there's going to be a hole in there because I have that same factor in the numerator and the denominator. So what do I have left that I can graph? Well, I have this x plus 3 left over, which I'm just going to be graphing that linear line. And when I hit the asymptote line of x equaling negative 3, I'm going to put a circle there, or my hole, because that would be the point of discontinuity. So if I do x plus 3, I'm going to use slope-intercept form, which means it crosses at 3. So 1, 2, 3. And then it has a positive slope. So it goes up 1 over 1, up 1 over 1, up 1 over 1. Or I can go down 1 to the left, down 1 to the left, down 1 to the left, which means right here, I need to have a hole because it cannot equal that point. And then I can have the remaining part of my line. And now all I have to do is just draw my line here. So it's a solid line till I hit the hole. And then here's the final line. Now, do you need to have the asymptote line drawn in here? No, you don't. I just put it in here so it helps me identify where I should have my hole. Now the last part is just finding where is the point of discontinuity. The point of discontinuity is here, x equaling negative 3. Or if you want to put the actual point down, it would be negative 3, 0, because that would be the point where the 0 is located. But we would just have the point of discontinuity is at x equaling negative 3. So that is a video on how you can find a graph of a reciprocal function and then graphing and finding the point of discontinuity.